Hello out there, this is Ed here at Sarasota Suncoast Technical College. I'm going to talk about CNC lathe setup, old school style, which would be manually touching off your tools. Two-axis lathe. Two-axis lathe, the center of the spindle is always a center line, and the z-axis is wherever you decide z0 to be. Most people use the face of the part. In my course here, there is some good fundamentals on setup here. I got an auto probe section and manual offset section. If you go into, I'm actually updating these videos. You have tip direction. And that, if you're doing manual setup, you have to enter that number on your offset page. And you also have to manually enter in the tool nose radius, the TNR. This is my setup sheet checklist, and this is my, not my CNC quick guide for Haas lathes by Tor Bergstrom. It's actually in your resources tab right up here, quick guide for Haas lathes. Right here. This is a good reference material. It's also on the Phillips Machinist app. Let me zoom this up a little bit here. Or if you take good notes, it's everything you need to know how to set up a lathe. Got the power up button, there's orientation of the chuck, the part, which way X and Z is, how to select the program from memory. I'm going to zoom this up a little bit bigger. This is kind of like our screen, the memory, if you're loading a program that's already in the machine. The older machines had floppy disks and they look kind of like this on the side. This is where the memory is. Loading from the USB to the memory. We usually try to load into memory, not running directly off of the USB. But you can drip feed from the USB, and usually you do that if the program's too large for the control. Because if you bump into that by mistake, it's going to disconnect. So you want to always have it in the machine. Tool change, right here. It's how to do a tool change. And handle jog, we always have the, let me get my picture out of the way here. The extra large button is always disconnected on machines, the 100,000th one. That's every click of the jog handle. Installing tools, this is like ours. We have the bolt-on holders for round drills or boring bars, usually. This is the side mount for all the turning tools, which right there is orientation in case you get lost. There are boring bars with the guide bushing there, and the little slot is for the set screws, and that's for orientation of the boring bar. And we also have this collar system for drills, or you can actually hold a boring bar there, but you'd have to get the orientation right. We don't have these VDI holders, but there's an example there how to do it, and this is a little one on changing inserts right there. Nice little pictures. We have fixturing methods. We have collets and jaws. We have clamping the chuck. The bottom one is the lathe chuck pressure, and if you have a tailstock, that's tailstock pressure. It says right here, generally 200 to 250 psi is a good starting point. Is the pedal. Notice the pedal's got the same marks, that's for the clamping. How to change chuck jaws. This is a nice little tip, or if you watch some Haas videos, use an adjustable wrench and another wrench, because you cannot lock the spindle and you don't want to have the power on when you're doing this. Machining soft jaws, he has a picture of a ring here. We have the same ring on that, so this boring the soft jaws to a certain size. Installing collets, we have a very similar system. And starting the spindle, and I use that to test out if even on manual lathe to make sure everything's running true, not vibrating. Is doing offsets race, setting tool offsets. Here's our offset page. This is using a reference tool. like a 1, 2, 3 block. I like a shim or using a gauge pin there. Using Z-face measure, verifying tool offsets. Setting manual offsets using a skim cut. Now you would skim cut that diameter, measure the diameter, and so you're going to do X diameter measure, get that number, measure what you have, and then add that number in so that this tool knows where the center is. Okay, inner diameter tools. If you're doing skim cutting, you either drill the hole in the middle and then start boring to find out where that tool cuts. No different than a manual lathe. If you like to preset the tool, if you line it up with the edge of this with a 1, 2, 3 block, you can probably get pretty close doing it that way. So you got to go off a known diameter if you're doing manual setup. You can even use that measured diameter to get that in there. So right here, he's using a micrometer to get the diameter, and there's all the procedures right there. Press, X diameter, measure. Now I could keep on saying it here, but you really need at the machine, you need good notes in order to be able to do it independently. Setting the offsets for drills. The drills are actually the same position all the time. So if you go back to a picture of the drill, back here somewhere, right there's a collet with the bolt-on holder. This circle is always the same distance on the turret, no matter what tool position you're in. So that X coordinate is usually the same coordinate. On our machine, if you press F2, it automatically puts the correct number in. So all you really need to set is the Z-axis. Now, if you have a turret with multiple holders, you may not, I don't mean multiple holders, multiple positions where they have a different X coordinate. Some people save that number, or they might do an indicator method that you see Mark Terryberry do in order to find the X coordinate center. All right, let's go back. Gauge block, skim cut, drill. So on the drill, you enter in the preset number, and then the Z-axis will be front of part, touching the front of part. And here's one with the presetter, but that's covered in the other videos. But these are all this, everything you see right here is, in other words, if you don't take good notes, if you have this with you and there's one at the machine, there's one of these books at the machine, you should be able to follow these directions and figure out how to do that. Here's like deploying the presetter. We have a pneumatic one here and some are manual. Manual, bring it down in order to get this square there. And what it's doing is, once it touches this coordinate right here, that sets the x-axis. Once it touches this coordinate, that'll set the z-axis. And that has to do with tip orientation. So if the tool is coming from this direction, x and z, and it doesn't have to look like the diamond, it's just tool orientation. So pretty much most of your tools are going to be number 3. All your drills are going to be number 7, and boring bars are going to be number 2. On our machine, that's all we use is 3, 7, and 2. These other ones are for, this would be number 4. We could possibly use a 4, and that would be a left-handed turning tool. But these other ones would be double spindles or side drilling or stuff like that. All right, work offsets. In a lathe, it's really shifting. So if you set all your offsets off the front of the part, I would leave the Z offset as 0. It's the same method when you do top of part on a mill. If you need to shift into the material a little bit, depending how it's programmed, then you can shift that coordinate a little bit. Same thing, top of part on mill, front of part on lathe. And usually your hand programmed parts are programmed to be Z0, so you want your Z0 to be in the material a little bit. Okay, but if you're doing all manual setting, usually you're doing it all with tool offset to get there, and work offset is just for shifting a little bit left or right. If you're using a probe system, you're shifting from where the probe is to where the part is. So they're still used in both. And you want to leave the x-axis at 0. Do not shift the x-axis. There's another one, setting offset with test cut, operation, everything's right here. Simulate the control. So I'm going to put up some videos of me doing this, and hopefully you'll be able to get a sense of how to do this before you even go to the machine. Okay, talk to you later.